We have done questions like this before. This is your very typical triangle question, but it's going to use your cast rule. Can we draw a triangle in the correct quadrant? It tells us that cos of theta is 3/8, but it's not in quadrant 1. Which quadrant would it be in? It's in quadrant 4. How do we use our cast rule to determine that? Well, we know that cos is positive according to our cast rule. That's either 1 or 4. And since it's not in 1, it has to be in 4. Trigonometry, number 1 strategy is drawing a triangle. Important though that you do not draw your triangle back to the y-axis. It has to go back to your x-axis because we need to use our reference angle. And if cos of theta was 3/8, we would know that the adjacent side is 3, the hypotenuse is 8. And you can use a squared plus b squared equals c squared. Do the mental math quickly. What goes inside the square root there? Did you get 55? Right? Because this is 64 minus 9. A squared plus b squared equals c squared. We know the hypotenuse c squared. We have to subtract the other side. Get the square root of 55. And then we can now write what sine of theta is. Sine of theta is opposite over hypotenuse, which will be the square root of 55/8. And because it's in quadrant 4, we have to make sure we add the negative. And tan of theta, opposite over adjacent. And because it's in quadrant 4, we have to add the negative. So very typical question. If you have to find stuff, can you draw the triangle? And now that we're into grade 12 and we have the cast rule, draw it in the correct quadrant. Always go back to the nearest x-axis so you're using your reference angle. Sometimes you're going to be tempted to go back to the nearest y-axis. Everything will go bad because you'll get the wrong opposite side, the wrong adjacent side. Things won't match up. Gut feeling to this question is no, because we just did our pie plate and we labeled a bunch of points and you're like, I don't remember labeling that one. Okay? But on your pie plate, there are so many other points that could be on there that we didn't label. We only did certain ones. There's an infinite amount of points. So now you're like, oh man, if there's an infinite amount of points on my unit circle, maybe the answer to this is yes, because that's a lot of right answers. But there's also an infinite amount of points that aren't on there. Oh my goodness. So, how do we determine if something is on the unit circle? We can either use the equation of the circle. If something's on the unit circle, you can use x squared plus y squared equals 1, which is the same. Some people just use the big idea. Sine squared theta plus cos squared theta equals 1. That's the same as the equation of the circle. If it is on the unit circle, then it would equal 1. If it doesn't equal 1, then it's not on the unit circle. So we need to find out okay. I'm going to do this correct, and then I'm going to do it almost correct and show a slight difference on how the exam you might lose a half a mark on. We want to check what this is equal to. Square root of 3 squared over root 3 over 2 squared. If I square that, I'm going to get 3 over 9. If I square this, square root of 6 times square root of 6 is 6. And 3 times 3 is 9. It's going to equal 9 over 9, which is equal to 1. So I can say, yes, it equals 1. It is on the unit circle. Okay? This would get you full marks on the exam. Sometimes students lose a half a mark because they do this. Can you see yourself if you wanted to check x squared plus y squared equals 1, that you would write equals 1 early? You don't know that yet. You don't know it equals 1 until you've simplified it. Now you have to show the work though. So if you would write this, they would take off a half mark because you haven't shown this yet. If you put a question, or if you wrote this, is like that equal to 1, no, then you're like asking the question, no mark is taken off. Okay. Sometimes students write, is it equal to 1, and then in the end find out it doesn't, and then they say no, but why did you say yes to begin with? So when we're trying to show something, we can't say it's equal to it until we've shown it. And they're very particular about that. We can't say it's true early until we've shown that it's true, and then we can say it's true in the end. So you can write a statement like this with a question mark. Is this equal to 1? Check the left side. Sometimes even people split it up into a left side and right side and make it like a proof. And we're going to do proofs, a lot of them this year. So you're going to see that technique later on. But to find out if something is equal to 0, you're going to use this and check, does it equal 1? If it does, the answer is yes. If it doesn't, the answer is no. And in this case, it equaled 1. So the answer is yes. If negative 12 over 13 comma y is a point on the unit circle in quadrant 3, find out what y is. They tell you what quadrant it's in. So we can draw something in quadrant 3 and go back to the nearest x-axis and label our reference angle. Okay? For me personally, I like to do this question this way. Using the big idea that points on the unit circle are cos theta comma sine theta, I know that cos of theta is negative 12 over 13. So I take my triangle here, and I say if this is my reference angle, I could draw a triangle where my adjacent side is 12, my hypotenuse is 13. A squared plus b squared equals c squared. 169 minus 144 is 25. Square root of 25. This is actually a beautiful triangle. It's one of the nice ones, like 3, 4, 5. The 5, 12, 13 triangle. And now that I know that, I would know that sine of theta is negative 5 over 13. Negative because it's in quadrant 3. Some students lose a half mark here because they stop. What did the question ask us to find? Y. I don't see any y's in my solution. But y is equal to sine of theta, so I have to write y equals negative 5 over 13 as my final answer, because the big idea by y coordinate is sine of theta. Okay? Now technically, that's how big our unit circle is, because I drew a triangle with a hypotenuse of 13. The unit circle has a hypotenuse of 1. Some people do this question when they draw the triangle. They keep that as 1 and say my x coordinate is cos, and they keep that as a fraction. I don't like that as much because then you have to do a squared plus b squared equals c squared with fractions. I like the bigger triangle, easier, but that would be right as well. And some people use the big idea formula and do x squared plus y squared equals 1. That's okay as well, but it uses fractions. So I like drawing the triangle with nice whole numbers as the best strategy because it makes your mental math the easiest. But there are other ways of doing this same question. Okay. We have to get really good at coterminal angles and figuring out where angles are. So if I give you something like 4,300 degrees, you have to find out what quadrant it's in, both with a calculator and without. So first of all, if you were finding it without a calculator, you could just divide by 360 degrees. Because 360 degrees is 1 time around, right? So if I divide it by 360 degrees, 4,300 is 11.94 times around the circle. Almost 12 times around the circle. If you went 11 full times and then went 0.94, does it make sense that it's going to end in quadrant 4? Quadrant 1 would be between 0 and 0.25. Quadrant 2 between 2.25 and 0.5, 0.5 and 0.75. And anything here between 0.75 and 1 as a decimal would have to be in quadrant 4. Now that's if you had a calculator. If you didn't have a calculator, then what I would probably do is try to find out what 4,300 degrees is coterminal with. And in fact, this question does ask that. It's asking, what's the first positive angle? In other words, if it ended in quadrant 4, what's this angle? How could I figure that out? Well, you can always find a coterminal angle by adding and subtracting 360 degrees, if you're working in degrees, adding or subtracting 2 pi radians, if you're working in radians, right? Because if I'm at 10 degrees and I add 360, I'm going to end in the same spot and be at 370 degrees, and it would be coterminal. So mental math-wise, this is probably what I would do. I wouldn't subtract 360 because I would know that it's going to be more than 1. Mental math-wise, I'd probably start by subtracting 10 of them. That makes sense? Subtracting 10, because it's easy mental math. That leaves me with 700 degrees. That's still more than once around. I'll subtract 360 again. That leaves me with 340 degrees. And now I know that 4,300 degrees is coterminal with 340 degrees. So we ended up subtracting 360 11 times. Although mental math, I would have done 10 times first and then done the 11th one after. Because 11 times 360, no, see, mental math not so easy with 11 times 360. It's not actually too bad. We won't go. Do you know the timesing by 11 strategy? It's 27. 11 times 27. 297. That works every single time. $11 times 341. Yeah, you better check that. I'm just gonna make sure I'm not making things up here. Did it work? 3,751? Yes? Whew. Okay. Pretty cool. Timesing by 11. And give me 7 random numbers. And I will tell you an 8th number. Okay? And I will make the answer divisible by 11. Okay? Give me a number.
8, 2, 6, 5, 4, 7. Wait, how many numbers?
You can stop whenever you want.
Okay.
I said 7, but one more.
7.
7 again? All right. So we got 7 numbers there. I'm going to go with 0. Take that number. Does it divide perfectly by 11? Someone have a calculator?
Yeah.
Is it work?
Yeah.
Yes! Perfect.
I'll do it again.
You don't trust me? Okay, give me 7 numbers again. I'll do a different color. Maybe I'm just lucky when I do blue. We'll go purple.
Sorry, I think you gave me
Okay.
off.
Okay. 6, 7, 8, 9, 2, 1, 4.
Okay. Well, I have to figure out where I was. Okay. That's how I'm going with. Is that divisible by 11?
Yes.
Yes! I showed this to you, but you forgot? Thanks a lot. The strategy for figuring out if something divides by 11 is add, subtract, add, subtract, add, subtract, add, subtract. And your answer in the end has to be divisible by 11, then the whole number is divisible by 11. So 8 minus 2 is 6, plus 6 is 12, minus 5 is 7, plus 4 is 11. Minus 7 is 4, plus 7 is 11, which is already divisible by 11, so I don't need to add any more. 0. 6 minus 7 is -1, plus 8 is 7, minus 9 is -2, plus 2 is 0, minus 1 is -1, plus 4 is 3. I actually had 2 different answers here. No, I have to subtract next. I'm at 3, I have to subtract, so I need to get to 0. But I could also have something like 8 minus 0 is 8, plus 8 is 16, minus 0 is still 16, plus 7 is 23. If I subtract 2, no, if I subtract 1, I get to 22. 22 is divisible by 11, so that number is divisible by 11. Yes.
So let's say you do say we do 8 digits. And
Yeah.
I say 7, 7, 7, 7, 7, 7, 7, 7.
1, 2, 3, 4, 5, 6, 7, 8. It'll be 0, right? Add, subtract, add, you're at 0. So I just add a 0 and make sure that would divide by 11. Because I was already at 0. So
That doesn't look like
that's crazy. Okay, sorry for getting off topic. That's 11s. I shouldn't have used the number 11. I shouldn't use any numbers because almost every single number triggers something for me that I can tell you a story about. So many stories, so many numbers.
That's okay.
That's all right. Now we're going to go to radians. And radians almost always, they get you to do things without a calculator. Okay? So you could, if you had a calculator, take the -23 pi over 6 and divide it by 2 pi and do the decimal thing and figure out what the answer is. And the negative means it's going in the opposite direction. But most of the time, they're going to get you to do radians without a calculator. And this is the strategy that I like to use with radians, is take the fraction part, the negative 23 over 6, and change it to a mixed fraction, which means negative 23 pi over 6 is equal to negative 3 and 5/6 pi. And now we're going to think in radians in terms of jumping by pi radians. Here's your circle. You start over here at 0. All the way around a circle is 2 pi. So halfway around the circle is pi. Agreed? And if you did coterminal, this would be 3 pi over here, right? And then this would be 4 pi here. And then this would be 5 pi. And then this would be 6 pi. And this would be 7 pi. How long should I go?
So keep going.
Keep going for like the rest of class? If I said, I wonder where 35 pi would end up. Could you tell me? You see that these are all, the odd numbers are here of pi, and these are all even numbers of pi here. So if I had 37 pi as an angle, it would be coterminal and end here at pi. So now we can use our thoughts in fractions to figure out quite quickly that negative 23 pi over 6, which is negative 3 and 5/6 pi, has to be in quadrant 1. How do I do that? Well, I look at the negative 3 first. And this would be like, oh, negative 3 would be going in this direction. This is 1, 2. Well, it's odd number. Does it make sense that negative 3 would be there? 5/6 is bigger than a half. Has to end in quadrant 1. You see how I used that bigger than a half to say it can't be in quadrant 2 because of the direction I was going? Negative 3 tells me, negative 3 gets me up to here, and then bigger than a half means I have to go another quadrant over to get to quadrant 1. This kind of mental math we have to be quick with, because I'm going to ask you mental math questions based on your memorization of your unit circle to be like, without a calculator, what is sine of negative 23 pi over 6? And in your head, you are going to be going like this. Oh, sine of negative 23 pi over 6. First of all, it's going to be part of my pi over 6 family, which is on my pi plate, and I've memorized it. And since negative 23 pi over 6 ends in quadrant 1, it's going to be coterminal with pi over 6. And sine of pi over 6 is a half. So sine of negative 23 pi over 6 is also a half. That's what our brain's going to do. We can go to our calculators, put our modes into radians here, and type in sine of negative 23 pi divided by 6. And sure enough, we get 0.5. We can get all of that from our pi plate, coterminal angles, and knowing how to find out what quadrant something is in. Whew. Okay. Okay. Now, I've got a sheet for you to practice these. And we'll do a couple together. You okay. So There are two things to get you to practice on here. This is for your, this is not to hand in, this is just for your ability to increase your mental math skills in radians. Okay? Assignment 1 says locate the angle, stating your answer in terms of the angle that fall in the first positive revolution of the unit circle. What that means is 13 pi over 6 looks like this. This is 13 pi over 6. It is coterminal with pi over 6. How do we find that out? How do we do that? Because our mental math skills with radians aren't there yet. Okay? So, what we're going to do is we're going to do the following. What's really nice about radians is that if the fraction is in lowest terms, and I believe that almost all of these are already reduced to lowest terms, right? I can't reduce 13 over 6 any further. If it's in lowest terms, 13 pi over 6 is part of your pi over 6 family. 19 pi over 4, what family do you think that belongs to? Pi over 4 family. What about 10 pi over 3? What family do you think it is? Pi over 3 family. Radians are super obvious that way, right? Degrees, not so much. Right? Is it obvious that, say, 410 degrees is part of your 30-degree family? No. I don't even know. I think yeah. No, 510 degrees is 410 degrees is something that's 50 degrees. Not easy in degrees. Okay? So, first of all, you know what family it belongs to. If you know what quadrant it's in, you can quickly tell what it's coterminal with. So, for example, 13 pi over 6 as a mixed fraction. Well, how many 6's go into 13? 2 and 1/6 pi. 2 is an even number. That would get me to here. 1/6 is less than half, ends in quadrant 1. What's your family member in quadrant 1? This would be coterminal with pi over 6. We'll do a couple together. 19 pi over 6. As a mixed fraction, how many 6's in 19? 3 full ones, right? That gets you to 18. You'd have an extra 1/6 left over. 3 and 1/6 pi. Can you tell me what quadrant that's in?
1.
Careful. Where's the 3? 3 would be here. Which direction are we going? We're going in this direction. And you need to go another 1/6. Quadrant 3. That's going to be coterminal with, what's your pi over 6 in quadrant 3? One bigger than your denominator, 7 pi over 6. So you see how those strategies for memorizing can come and help you in figuring this out. So I could figure out sine of 19 pi over 6 would be -1/2. Because sine of pi over 6 is 1/2. Then in quadrant 3, sine is negative. Whew. Mental math is coming up. If you had something, let's do number 5 next. 101 pi over 4. How many 4's go into 101? 25, and you'd have, how many left? 25 times 4 is 100, you'd have 1 left. So this is 25 and 1/4 pi. 25 would be here, right? 1/4 more would be in quadrant 3. It's going to be coterminal with, what is 1 more than our denominator? 5 pi over 4. So this is assignment 1. Can you practice your skills in figuring out just what it's coterminal with in what quadrant? How fast can you find out it's in quadrant 3? and then you state your pi over 4 family member in quadrant 3. In assignment 1, in 9, 10, 11, it says just ignore the sign, just think about the angle. Then it says assignment 2 is once you've found your reference angle, state the coordinates. So here I have pi over 6. My coordinates would be root 3 over 2 comma 1/2 at pi over 6. Here I have 7 pi over 6. My coordinates in quadrant 3 are negative root 3 over 2, negative 1/2. 5 pi over 4, quadrant 3, negative root 2 over 2, negative root 2 over 2. So we know our pi plate, right? What we're memorizing it for tomorrow so that we can get answers like this with questions.
I just need like clarification. So in the mixed fraction, how did you like find where the whole number lands on the lines?
Okay, so that's a good question. Like in the mixed fraction, the whole number here is a 25. The whole number here was a 2. The whole number here was a 3. Okay? And I'm going to just go back to this slide because I think this is where we started that idea. And if I think about my circle, it starts with 0 here. Halfway around is 1 pi. All the way around is 2 pi. Then another one would be 3, then 4, then 5, then 6. So odd ones will always end here,
Right.
and even ones will always be on the positive x-axis. So then when I got to, say, 25, I noticed that's odd. If I did 25 pi, I can't. Already hypnotized through this one. Be careful. 25 is going to end here, right? And then we have another 1/4. That's less than half, so it has to be in 3. If it ended up being 25 and 3/4, well, 25 would still end here. 3/4 more than half, then you know it's quadrant 4. Yes.
So like hypothetically, let's say you get like the number like 3 and 1 over 2. And then like would that ever ask what quadrant?
Well, 3 and 1 over 2,
Because that would be like halfway.
it'll be right here. It's in quadrant, technically it's in between quadrant 3 and 4. It's an axis family.
So
So then you would just use your axis family stuff, but it's neither positive, like, it's going to be, like if it's cos is your x coordinate, it's 0. It's neither positive nor negative. If it's sine, it's negative 1. But sine is negative in 3 and is negative in 4, so it'll be negative on the axis family as well.
so then if you were to get like 3 and that was it, then it would be like
It's
it would
perfectly there. So sometimes you get your axis family. What we're going to have, since we've only done pi over 3, pi over 4, and pi over 6, those are the only fractions you're going to have to reduce. Question. Now get your sense out.
So what if it's like 3 over like 2/4? What if the 2/4 reduce into like
A half. Yeah.
half?
So we're all, like in all of these, like technically 18 pi over 8 isn't reduced. Reduce it first. This is 9 pi over 4. That's in lowest terms. 9 pi over 4 is 2 and 1/4 pi. You know it's going to be in quadrant 1. Because the 2 is stopping there. Now if it was negative 18 over 8, which reduces to negative 9 over 4, which makes it negative 2 1/4. Now we're going in the opposite direction. So this 2, the 2 still ends here, but now the quarter more that is going in this direction. That would be in quadrant 4.
How would the negative work again?
So the negative, let's do, are there any negative ones in here? There was just a little negative one. There's boring negative one. Let's say we had a not boring negative one. Like negative 22 pi over 3. This is going to end in quadrant 2. Why? Because negative still stays there. How many 3's going to 22? 7. You'd be left with a third. It's negative 7 and 1/3 pi. So the negative 7 tells you here, right? Because it's an odd number. The negative means you're going in this direction. So now the 1/3 more has to keep going in that direction. It's less than half, has to end in quadrant 2. So take some time to do it's a lot of mental math that we're doing just to figure out what quadrants things are in. And this assignment is for practicing that. Okay, we will continue with this handout. Once the handout is done, you will have 2 days to get your take-home quiz done. So we're basically done all of 6.1 to 6.3. So you can do most of your take-home quiz, but it most likely will be due. We're going to finish this tomorrow, so your take-home quiz is going to be due on Thursday.
I think you should do Monday, so you get the full.
Yeah, so you'll be almost ready for your next one then. By Thursday. So,
Make a practice.